Building tunnels has to be one of the greatest feats of engineering imaginable. We literally carve paths through solid mountains and deep under sprawling cities. It's incredible. But deep down, far from daylight, that incredible work comes with some massive hidden dangers. Today, we're going to decode the blueprint for survival in that world, the Indian standard IS 4756. Just imagine it for a second. You are deep, deep underground. Millions of tons of rock and earth are right above your head. The only light is artificial, and the only way out is the long, narrow tunnel you just came through. So, what is the one thing standing between you and a potential disaster? It's not just skill, and it's certainly not luck. It's a set of rules.
Okay, so here's our game plan for this explainer. We'll start by looking at the dangers lurking down below. Then we'll get to know the rulebook itself, IS 4756. After that, we'll break down the really critical parts, the basic gear and rules for everyone, how to handle things that go boom, like sparks and explosives, and of course, the very air you breathe. And finally, we'll look at the heavy price of what happens when these rules are ignored.
Right, before we can really appreciate the rules, we first have to understand the risks. Tunneling is nothing like building on the surface. Down there, the environment itself can feel like it's actively working against you. The very ground you're digging through can be your worst enemy. The standard actually has a specific name for the most treacherous conditions. They call it running ground. Now, this isn't just some loose dirt. Clause 2.1.3 defines it as stuff that's so unstable, it can basically flow like a liquid. Think crushed rock or sand saturated with water that can just collapse with zero warning. The fact that this is defined right in the code tells you it's built on the hard reality that sometimes you're digging through a disaster just waiting to happen. So, how on earth do you engineer safety in a place that's so unpredictable? Well, you create a super detailed, absolutely non-negotiable set of rules. And that is exactly what ISO 4756 is. It's a rulebook for survival, written from decades of painful, hard-earned experience. And listen, this is not some document that was just whipped up overnight. It was first published way back in 1968, and it's been updated ever since. It's basically a living library of knowledge. It pulls together lessons learned from accidents, engineering breakthroughs, and best practices from all over the world. Every single clause, every little rule is in there for a reason. And that reason, sadly, often traces back to preventing a tragedy that's already happened before. All right, let's get into the specifics, starting with the absolute basics. These are the foundational safety rules that apply to every single person who steps foot inside that tunnel. These are the non-negotiables. So, your first line of defense, laid out right there in Clause 4.2.1, is your personal protective equipment. It seems obvious, right? But the code makes it mandatory. Helmets for falling debris, steel-toed shoes to protect your feet, gumboots for wet conditions, and, this one's crucial, safety belts whenever you're working on an incline or in a vertical shaft. This is the basic armor every single worker has to wear. And get a load of this detail, 5 liters. According to Clause 4.3.2, that is the minimum amount of drinking water that has to be provided for every single person for every shift. That just shows you the level of thought here. It's not just about preventing a catastrophic rockfall, it's also about preventing dehydration and protecting a worker's most basic human needs. Of course, the code plans for the worst. Section 4.1 is all about what you do when things go south. First aid has to be close by and easy to get to. Every single shift has to have at least one person who's trained to use it. Stretchers have to be waiting at the entrance. And for bigger crews, over 50 people, there has to be artificial respiration equipment ready to go. The code basically assumes an accident is going to happen and demands that you're prepared for it. Okay, now let's level up to the high-energy hazards. Tunnels are just this volatile mix of heavy machinery, high-voltage electricity, and, explosives. Trying to manage all that in a confined space is one of the most critical parts of this safety code. Just look at the difference here. Based on Section 5, it's night and day. On the left, you've got a recipe for absolute disaster. Frayed wires, flammable stuff stored right next to a switchboard. But on the right, you've got the IS 4756 standard. All high-voltage cables have to be armored and grounded, the area around switchboards is kept totally clear, and fire extinguishers for electrical fires are always on standby. It's the difference between a safe site and a death trap. And the precision in the code when it comes to explosives is just remarkable. Clause 6.3 lays out exactly how to move them, and the rules are so strict. Explosives and their detonators, they have to travel in separate, insulated containers. If they're on the same cart, there's a mandatory 45-centimeter gap between their compartments. And the locomotive has to pull the cart. It never pushes it.
Every single detail is designed to prevent friction, sparks, and accidental impact. So what happens when the explosives don't go off? It's got to be the most tense situation underground. But clauses 6.5 and 6.6 give a clear, calm protocol. Step 1, kill the power immediately. Step 2, wait. You do not rush in. There's a minimum wait time of 15 minutes to make sure there's no delayed blast. Only then does the blaster, and only the blaster, go in to carefully figure out what went wrong. This procedure replaces pure panic with a clear process. But you know, some of the deadliest threats in a tunnel are the ones you can't even see. I mean, rockfalls and explosions are pretty obvious. The air itself, though, that can become a silent killer without constant, careful monitoring.
Okay, this table from clause 7.2.2 is frankly chilling. Look at these numbers. These are the absolute maximum amounts of these deadly gases allowed in the air. Carbon monoxide, you can't have more than 0.005%. Flammable methane, less than 0.5%. The margin for error is practically zero. These tiny, tiny amounts that you can't see or smell can be the difference between life and death.
And because those limits are so incredibly strict, the testing has to be relentless. Clause 7.2.3 says the air has to be tested at least once every day, but, and this is the important part, it also has to be tested after any event that could change what's in the air, like a blast, which releases fumes, or a rockfall, which could release trapped pockets of gas. Safety isn't a set it and forget it kind of thing. It's constant vigilance. And it's not just about poison gas. The code also goes after long-term threats, like the lung disease you can get from rock dust. According to Clause 7.3, only wet drilling is allowed. Why? Well, the water traps the dust right at the source, stopping it from ever getting into the air. You combine that with powerful ventilation and mandatory medical checkups for workers every 3 months, and you're protecting their long-term health, not just their immediate safety. Okay, we've seen the rules, we've seen the procedures. Now we have to talk about the reason they all exist. What happens when the code isn't just bent, but completely broken? What is the ultimate cost of negligence? Every single rule we've talked about is directly tied to preventing a specific deadly outcome. The cause and effect here is undeniable. If you ignore ventilation rules, workers get poisoned. If your electrical work is sloppy, you get fires and people get electrocuted. If you get lazy with explosives, you get a catastrophic, uncontrolled blast. And if you don't properly check for and remove loose rock, the whole tunnel can come down. There is no such thing as a minor safety violation when you're that far underground.
In the end, a document like IS 4756 is so much more than just a technical manual. It's a pact. It's a promise from the engineers, from the supervisors, from the company, to every single person who walks into that tunnel, a promise that the #1 priority is making sure they walk out again at the end of their shift. Understanding these standards is absolutely critical if we want to engineer a safer world. For more deep dives that break down the codes and regulations that shape our industries, make sure you subscribe to the ISO Automation Lab. Thanks so much for watching.